So here's your vocab for today. A rate is a ratio of two quantities using different units. So we already saw this definition last class, but I told you that we were going to talk about it another time. So a rate is a ratio of two quantities with different units. And a unit rate compares a quantity of one unit of another quantity. So a unit rate, miles per hour, right? 60 miles per hour. Why is that a unit rate? Well, because it's comparing a quantity, 60 miles, to one unit of another one. So 60 miles for every 1 hour. Or you get 25 cents, or maybe it's 5 cents per pencil, right? In the vending machine. Anybody ever bought a pen at the bookstore? Pen or pencil or anything at the bookstore? What'd you buy? You bought a pen? How much was it? Give me a random number that doesn't matter. $1. Wow, this is a sweet, awesome pen.
I bought a pencil, it's 25 cents.
So you bought a pencil, so that would be 25 cents per pencil. That would be called a unit rate. Because you could buy 4 pencils for $1, right? Could you buy 4 pencils for $1?
Yeah.
So the unit rate would be comparing a quantity, pencils, to one unit of another quantity. The key word there is one, right? Unit rate. So you could buy 4 pencils for $1 or 1 pencil for 25 cents. Or the other way around would be 25 cents per pencil. Okay? That's a unit rate. Equivalent rates have the same unit rate. So rates that are equivalent, we have the same unit rate. So let me give you an example. Well, let's use St. Lollies. All right, so a unit rate in this case would be $1 or 4 pencils for $1, right? 4 pencils for $1. What would be an equivalent rate to 4 pencils for $1? 40 pencils for
$40.
$10. Or what about 8 pencils for $2? So those would be equivalent because they would have the same unit rate. So there was an example that we had in our notes last time that said they drove 60 miles in 2 hours. $90 miles in 3 hours. Why are these equivalent rates? Why are these both equivalent rates? Because if you simplify them both, right? What would the first one simplify to? 30 miles per hour. What would this one simplify to? 30 miles per hour. So these two would be equivalent rates because they have the same unit rate. That's important for us. Okay? So here's kind of some algebra for what it looks like for unit rates. So if this is a rate, A to B, right? So A to B, anything. Anything A and anything B. A to B, the unit rate would be A over B to 1. That's the pattern. So if I have a rate 60 to 2, 60 to 2, what would the unit rate be? It'd be 60 over 2 to 1. What's 60 over 2?
30.
So it'd be 30 to 1. 30 to 1 hour. 30 miles per 1 hour. That's how you find a unit rate. You guys remember what we did last time with ratios? We found its value, right? We found its value. That's kind of what we were doing. For the most part, we were kind of finding its unit rate, right? So this is the idea. Whatever ratio you have, or rate, right? If a rate is comparing two different units. You just take the first one, divide it by the second one, and what do you get? You get your unit rate. So here's our first example, and the only real example we're going to be doing a lot of today. Okay? You pay $350 for every quarter ounce of gold. Yeah.
The thing.
Yeah. On the back one slide. Sure.
No, the other one you were just on.
Yeah.
I was about to solve the problem.
Oh, well, we've got two different methods we're going to look at. What is the rate here? Just unsimplified. Just what is the rate? $350 to 1/4. That can also be written as
0.25.
350 to 1/4, right? And typically we want to write that with units, but for to 1/4 ounce. Ounce. Okay? So it's 350 to 1/4. So method A is this idea. I want the second unit to be 1, right? To be a unit rate. If I want to find the unit rate of this, I need the second part of my rate, the second part of my comparison to be 1. Well, how many quarters are there in 1? Well, it's 350 for every 1/4 ounce. Which means that there's another 350 for another 1/4 ounce, right? You with me so far? Which means there's another 350 for another 1/4 ounce. Which means there's finally another 350 for another 1/4 ounce. So what did we do? Our method A is, well, let's just add up the pieces until the second part is 1, right? So split it up into a series of multiplication, right? What do I have a 1/4 ounce, I need it to equal 1 ounce, so I just add up. Add up the pieces. Or in other words, I make it so the second rate is 1. Or the second part. And what do we get? Make it so the second part is 1. Well, then what do we get here? 350, 350, 350, 350. What do we get? 1,400. And when we add 1/4, 1/4, 1/4, 1/4, what do we get? We get 1, right? With me on that? Cool? The second method is to divide. Right, because we saw that, what does the algebra say? It says that the ratio A to B, if I want to find the unit rate, it would be A over B to 1, right? So when I divide, we're thinking A over B to 1. That's what we're thinking. All right, so let's do our division. 350 to 1/4 would be 350 divided by 1/4, right? That's the division. 350 to 1/4 is 350 over 1/4. Questions from, that was from last time? And we know that that's a little bit easier to be seen like this, 350 divided by 1/4, which we like it writing like this, 350 times 4 over 1. And what do we get? 1,400. So what is our unit rate? It's going to be $1,400 to what? To 1 ounce. Or in other words, we can write it like this. $1,400. Oops, sorry, that I started to write the 400. $1,400 per ounce. It's another way of writing it. So this would be our unit rate, $1,400 for every 1 ounce, or $1,400 per ounce. Sometimes we're going to need to use this method. Sometimes we can use this method. To be honest, on this problem, I would have used the first method. I would have said, okay, I want the second rate to be 1. That's 1/4 times 4, right? Right? You with me on that? 1/4, 4 times would be 1 whole. So I would take the price 4 times. I would have used method A on this one. There will be a few problems later that I would have used method B on. I probably wouldn't have used method B on this one. I think that it's easier when you have a fraction, if possible, to just realize, okay, 1/4, how many fourths are there in 1 whole? 4 of them. So I need the first number in my rate, need it 4 times. 1, 2, 3, 4. On this one, we can pick our method. I'm going to do it both ways. But deal with some Kool-Aid. Drink that Kool-Aid, ladies and gentlemen. The directions on a container of Kool-Aid says to use 5 scoops of Kool-Aid for every 10 quarts of water. We got 2 questions here, right? The first question is how many quarts of water should you use for every scoop of Kool-Aid? So that means our comparison will be what? Our comparison will be quarts to scoops. Remember, order matters when we're doing a ratio and a rate, right? Order matters. So what is our ratio here? Quarts, it'd be 5 scoops, 10 quarts. This is 10 quarts to 5 scoops. Well, which method do you think would be best here? I just use the division here. This division is really straightforward, right? What would be the division here? 10 divided by 5. That's super easy. It's going to be what? 2 quarts would be the answer to our question. Now, another way to look at this is, what common factor do they both have? They both have 5, so could I divide them both by 5? Could I divide them both by 5 and get 2 quarts to 1 scoop? That's another way to do these things. That's another way to do these. Pull out a common factor from both of them, so that way the second ratio becomes 1. We divide them both by 5. Hey, look, I did that. Now, the second one is a different order, right? How many scoops of Kool-Aid should you use for every quart of water? This one is scoops to quarts. So this one is slightly different, isn't it? This one's going to be what? How many scoops? 5 scoops to 10 quarts. So the question is, how many scoops of Kool-Aid should you use for every quart of water? This one is a little bit different. I probably should use division for this one again. What would be my division for this one? Remember, order matters. Ashley? 5 over 10. Which is half a scoop. The other way to think about this is, all right, well, if I divide both of these by 10, I'll get 1 quart, right? If I divide quarts by 10, I'll get 1 quart. You with me on that? So that means I need to divide 5 by 10 as well. It's a common factor that I'm dividing out. It's another way to think about it. I'm trying to get you to think about these in different ways, right? Division here or multiplication. This one, method B is probably better. But the first example, I would have used method A. I would have been like, oh, okay, there's 1/4, so I need 4 of them. So I just multiply by 4. Here, division makes more sense because we're working with whole numbers especially. Okay? Division makes a lot more sense. How many scoops of Kool-Aid should you use for every quart of water? Well, I need to use half a scoop. So the question is, what if I wanted to make 20 quarts of Kool-Aid? 20 quarts of Kool-Aid. What about this? What if I wanted to make 7 quarts of Kool-Aid? How would figuring this out be helpful?
Because then you know how much you need for that much quarts. You can do that like 2 more times, or 5 more times.
Or 5 more times, or 7 more times, or 23 more times. So where does a unit rate help us? Well, it helps us get a baseline for our problem. What if the question here said, the directions say we need to use 5 scoops of Kool-Aid for every 10 quarts of water. How many scoops will I need for 7? What if the question was that? What if the question was, how many quarts will I need for 7, or how many scoops will I need for 7 quarts of water? Do you see how this can be helpful? We figure out the unit rate, and then what would I do with that? It's half a scoop per quart, so what would I do with that if the question was, how many scoops will I need for 7 quarts of water? Then you just multiply it by 7. Unit rates are really helpful because it helps us scale things larger or scale things smaller. Okay. All right, there's a couple of problems I want you to try. With your partner, I want you talking about this one. answer the question being. The question there, I'll read out loud to help you out. It's on your notes, but I'll help you out by reading it out loud. There is a quarter gram of fat for every 1/3 tablespoon of powdered peanut butter. How many grams of fat are there for every tablespoon of the powder? I'll give you a minute or two to try that one. Give it a shot. Ready, set, go. Look at your methods. Decide which method you want to use. Talk to each other. Decide which method you want to use.
So 1.
So I just showed you what I did in my head. But I use method A on this one. So I use method A because I know that 1/3 times 3 is 1, right? So I just take the first fraction, what do I do with it? Multiply times 3. So I just showed you what I did in my head. I said, all right, there's 1/3 tablespoon of peanut butter. I want 1 whole tablespoon, so how many thirds will I need? How many thirds will I need?
3.
I'll need 3. So how many quarter grams of fat will I need? 3 quarters. That's how I did. I did method A. Now, if you use method B, what would you do?
1/4 times.
Method B is a division problem, right? 1/4 divided by 1/3, which is 1/4 divided by 1/3, which is 1/4 times 3/1, 3/4 grams. Either way is great, but I use method A. In my head, I use method A for that one. Okay? All right, you guys got 2 more to try. Ready, set, go. Go ahead and try both of these. Talk about them with your neighbor. Please don't try these independently. Please try these with your neighbor. You can pick which method you want to use, y'all. I'm only going to use one method for these. Questions? So I use method B for both of those. Notice different times call for different methods, right? I used method A on the previous slide, right? I used method A on this one because I was dealing with a fairly straightforward fraction, right? 1/3. That's pretty easy to figure out how to get 1/3 to 1, right? How do I scale 1/3 up to be 1?
3.
Yeah, I multiply it by 3, but so you might be thinking, anytime I use fractions, I just want to use method A, right? Well, probably not. Why is this one not a nice fraction to scale to 1? Is there anything I can multiply by 3/10 really easily to get to 1? No, it's not like this is 2/10. If this was 2/10, I just multiply it by 5, right?
1/5.
Multiply it by 5, it'd be 1/5. I just multiply it by 5, and then multiply that by 5, but it's not. So I used method B because I wasn't sure what to scale by, right? What should I multiply both of them by? Well, I was unsure, so I just did my division, right? Keep change flip, did the division, 10/12, and then 5/6 gallon per mile. Notice unit rates should have a something per something, right? Should be unit compared to 1 unit of another one. So dollars per 1 ounce, or gallons per 1 mile. And you don't have to put the 1 there because it's implied. Okay? Questions?